Hello everybody, welcome to another stream. How we doing? Um, so last stream we got a camera system in. So basically we can look around in the world. You notice we have a really big sort of field of view, but that's just because I was testing stuff. But so we've got this model here that we can look around, and we can sort of go up and down in the world and sort of just move around it, which is pretty cool, and also go through it. So now the next thing to do is make multiple of these guys. Today we're going to be working on having instances of models. Hey Catpain, how you doing? Yeah, I've increased the size of my balls since last stream. Been working hard on that one. Yeah, off stream I put in a bit of training and yeah. Okay. Don't know what's going with that one. But yeah, so since last stream I have I was thinking ahead. I was thinking about um how I was going to do occlusion culling and um, um, also having LODs, right? Different. Um, so we can account for when you go really far away from the camera. Maybe we substitute a group of 4 or 8 by, sorry, 2 by 2 by 2, right? So 8 spheres. We substitute them for 1 sphere. When you get so far out from the screen. So I've been thinking about all of that. So we're starting simple today. We're just going to get multiple instances working, and then we're going to build on top of that and do the more complicated stuff. But yeah, it's going to be cool. So I've just increased the size of the balls. So now they're each grid. Say each grid is like, so we place the spheres inside a grid, basically. So you can imagine each grid cell being 1. And I think each one of these balls is about 1.4. So they actually go bigger than a grid cell. And I don't know if this is where we want to go. We got 2 choices. We can either have like larger balls than the size of a grid cell, or the size of a grid cell, but then we sort of offset them every other cell across the X and Y and Z or something like that. So you basically get them. There's my Milton, so I can draw it. But yeah, so we can basically have so rather than having like a grid of balls like this, instead we can offset the grid a bit. Every other, and then you sort of, yeah, you get less holes basically. My spheres are not drawn very well, so there's clear gaps, but you get less holes than this. But I'm not sure what I want to do. It's easier just to increase the size of the ball so you get no gaps. And then we could do occlusion culling. A lot easier. Oh, that's not good, is it? Getting some balls there appearing at the side. Sure, renderer's doing that. Huh. Hey, Skunkinada. No, it's a ray tracer, but yeah, kind of the same sort of thing, really. Ray marching, ray tracing. Hey there, not so red. How you doing? Good to see you. How you been? Yes, it's just a ray tracer. We've got 3 different ray tracers. That are running at the same time, kind of thing. Oh, bit of a bug there as well. What one is that? It's not the BVH one. It might be the screen. Could be the Froxall. Sure, look into that. Oh. BVH, just disable that one. We'll disable the Froxall renderer. Let's see if it happens on the this is the screen space tile renderer. It doesn't happen on the... Let's put the Froxall renderer back. Oh, we're getting some glitches with the Froxall renderer. Is it the bigger balls? Yeah, we've got some bugs with the Froxall renderer. No. I think it's not binning it in all of the bins properly. That it overlaps, and that's fine. So, well, let's start with the screen space renderer. Good morning, Sully. It's afternoon here. Theorem for World War 3. I don't know there was a World War 3. What's going on? Too busy just trying to make games. What's going on? So the plan with models, so you know, we want to build up a bunch of features basically, because the idea is we want to essentially just build a test scene, right? So the aim is to build sort of like a kind of like a test scene with, you know, a bunch of models. So a sort of stress test scene with a bunch of models, because I want to see like I want to see how many spheres I could render or something like this as a baseline, and it allows us to really test out our yeah, because I want to implement a bunch of different features, so I need to have like an actual scene, right? So yeah, I guess. So we can test performance and sort of like and test sort of graphical features, right? Something like that. So right now we just need to have like, you know, multiple instances and, you know, different models. So we need like something more than that dumbbell ship, right? Because it's the thing is about the dumbbell ship. If you give it a run, what you'll find is, you know, I guess it's a bit wide, but it's kind of small, and like it's just got, you know, these balls are quite big as well. Maybe we can make them smaller, and you know, there's a whole bunch of, you know, you can imagine like having like a floor that just goes from the start of the camera all the way off into the distance. That's going to be an awful lot different to just this small little model here. Yeah, so you need to have a bunch of different models, basically, all shapes and sizes and stuff like that. Two. So we need to have a way. So we'll just build a bunch of different models by just having a 3D volume, and we'll just use sign distance fields to sort of construct these different models for now. But I think we should probably have a way to author these like in the application, because it could be quite fiddly with code sometimes, right? Leave dragon. Oh yeah, news. Yeah, I know, right? Like they just try and get any headline, isn't it? But there is some unfortunate stuff going on, right? Not to play it. But yeah, they definitely do play on that, on those play on moments. Well, license is the code under. So the license is, I can pop it up on screen. It's a little custom one. So effectively, for everyone who has a license, you can share the code, your changes with the code with. So I don't want people to be able to like take my code and essentially ship it. But the code can be used for learning purposes, basically. So put it this way: I'm not going to be annoyed if people get inspired by a little bit of code, take a little bit of code. I'm not. That's not what this license is about. What the license is about is people like copy and pasting the whole thing, or basically stealing a major idea or group of ideas and making it into something else, right? And then, that sort of thing. But if it's just like, there's some maths functions, or it's quite cool how that shader was done. It's not that bad of a. It's not like, but yeah, like learning from like being inspired by something basically, is fine. But in terms of like just literally copy paste reskinning, that sort of thing. But yeah, so if anyone has like a license, they can share code with someone else who has a license. And yeah, for people who donate, they get to sort of keep the code up to the last version that they donated for or something like that. And they get all prior versions or whatever. Can't protect your ideas with copyright. That's fine. So yeah, there's outline on the spheres. Can't protect ideas. Yeah. So yeah. So what I kind of meant by that is like, basically I've nearly finished the game. Someone can't just like copy paste the project, change it a little bit and ship it, that sort of thing. That's what I'm saying. Obviously the idea of the game, I could clone some other game, right, and make it from scratch or whatever. But yeah, it's mainly just like talking about basically taking the implementation, right? The outlines. Yes, you are tripping a bit. Not. Yeah. So basically, remember the AI dust? So sorry, AI. I read Davos's thing and I got AI in my head. Why is it not showing up here? Yes, the outline's been turned off. Okay. So basically, we've got a bit of anti-aliasing that happens in the shader. For some reason, it wasn't happening there. So effectively, there's a pixel border which goes around, and it tries to do anti-aliasing. But that code broke at some point, so now it just gives off a border. basically. It looks pretty cool though, but I don't think it's going to be something we keep because when we do like a system, an LOD system, like, you'll see clear pop in when you do this, unless you'll see clear pop in basically, unless you do it when it's like sub-pixel. Yeah. So I would probably minimize this. Maybe an outline around a whole object could be fine, but an outline around each sphere is probably not a good idea. What's your take on AI code completion, training on it? So yeah, I haven't got it on GitHub. I've got it on GitLab though. Yeah, so it kind of sucks that Microsoft basically just, and I'm sure a bunch of other people are like training off of all the open stuff on the internet. Um, you know, um, it does kind of suck. But when you actually use the tooling, right? I've tried to use the tooling. Right now, it's not that great, right? It does make a ton of mistakes. And people will be like, oh yeah, but human beings make tons of mistakes. I'll send write a page of code. But this is a computer. A computer is meant to be this thing where you give it 2 plus 2, it knows it's 4 right away. Eventually, it's going to be really good though, and it'll be able to write like a whole file and then maybe a whole program for you at some point. And it would kind of, yeah, line's definitely blurry. I'm not sure how I feel about it. Like I feel it's fine if it's if it's like a community thing and it's stuff provided like an open source project which provides help for everybody. It's probably I think it's probably ethically fine. But if it's a company making a ton of money out of it, then I feel probably less fine about it because they've just come along and taken other people's work for free, and they're not giving it away. Well, maybe they give it away for free, right? But then they're sort of trying to profit off of it, right? And all they're doing is providing a service on top of everyone else's work, right? So that's where I think that it's a bit immoral. They can make money out of my Rust shoot 'em up game, but right. Yeah, the thing is, the reason why I'm doing this sort of model where because I want to try and do something different, right? Everyone else just tries to sort of like either I don't think many people open source their games. There's a few open source games, right? But it'd be interesting if, maybe people just sort of build their game commercially and then they sell it. It's like what happens if, and I haven't designed the game yet, but what happens if when I design the game, part of that input variable is going to be like, well, the code is going to be out there, right? Obviously, when we do, if we get a chance to do a console port or something in the future, that's obviously going to be closed sourced, right? And then that's where I could probably sell something more standard sort of way. But in terms of that from a PC perspective, the code's going to be out there. Can we use that to our advantage in some way in the game design, right? Where it doesn't also exclude the whole console owners in the future or something like that. And I feel like maybe we could come up with something a bit different. Like I'm all for just doing stuff in a different way. you know, especially when I'm just playing around and you know, this isn't my sort of main gig, right? So there's room for that, which I think is pretty cool. I see where this is going. Didn't it will get crazy? Eventually, make your own TV shows. It may be. I don't know, because the problem with current AI is it's based on they basically rate they're inspired by how the human brain works, and the human brain, as much as it's really great, like the way it works is it's basically blurry, right? It's got like a blurry resolute, like the resolution of the brain is very blurry, you know, and we're sort of building our system on top of that kind of, or we're building that sort of into current AI. Maybe we could have like a left brain and right brain type of thing where we can have more of the logical number crunching brain side of the brain and the more sort of blurry, you know, side of the brain. But yeah, it's like yeah. Where was I going with that one? Yeah, I don't like. Yeah, current AI has to change a lot for it to do anything of big, you know, like a whole TV show, a whole game. But we will probably get there in not too long. I found one non-trivial source code on GitHub, my pet language. I like to think giving away something sort of as used the other. Yeah, exactly. That's right. Yeah, it does. It's just gonna. Yeah, I think some people maybe. Oh, why is my phone disconnected from the chat? I think what's interesting about the AI thing as well, it's a bit like, you know, when everyone was going vegan. There's people who just do the complete opposite thing and just go like full meat, just eat fully meat. The funny thing about AI eating up all this open source code on, I think some people were just now and eating up the whole internet. People just trash the internet with just a bunch of garbage. So these sort of AIs just come and chew up on a load of crap and get dumber. And it makes them sort of try harder and find the correct sort of data to feed it into the machine rather than just scraping off the internet. Or just creating more noise for the robot for the people to filter through. But yeah. How about synthetic data? No, is this where they sort of create data, like they procedurally create the data or programmatically generate data to then feed into the robot? Is that what it is? Yeah, so create multiple model instances. We probably then want to work on some form of like LOD system, LOD, and probably LOD system and occlusion. Three occlusion, buffer, v2. So in a second attempt at that, because we tried it and it was like, that wasn't as good. And we thought we was going to go and purely use a BVH for ray tracing. Turns out that's great for in-world stuff, but from the primary screen, we could probably do something better. So from primary screen, we probably will benefit from LODs. So like a LOD system with what are they called? With model clusters, right? So kind of like mesh clusters, if you're familiar with that sort of stuff. So this will really help when you have like a massive model which fills the hole, which goes really close to the camera but also goes really far. You can sort of break it up into these little clusters, and they're kind of like their own little small models and have different LODs basically. So yes, that'll help all of that. And then after we've sort of done that, we probably want to have a way to sort of quickly make little models in the actual yeah, so I'm not sure if we'll do this at step 4. We might have to create some other sub steps, but we'll see. We'll probably make some form of like model editor of some kind. Okay, maybe 4 will have some way of playing around with like variable ball size, right? Where we want, I don't, wait, this one might move around, but essentially the part of the style I think I want to go with is not fixed ball size, right? Around the edges you'll get smaller balls, and then on the insides they'll just get bigger, so there's just so we're tracking less balls, right? But we also want to have the ability when you're sort of editing this to sort of say, no, don't make sure they are, you might want them to be bigger on the outside, so you can sort of, you know, brush over it with a, you know, with a tool, and then they'll stay big. But yeah, we need that in there as well. It might, yeah, I might change where that goes exactly. But yeah, something like this is what we're going to be doing probably over the Christmas break. AI making day for AI, amazing. That's one way to bugger it up, isn't it? Wow. May Mel Mel oh Mel Furion. Thank you so much for the sub. Appreciate it. Welcome to the club, my friend. Thank you, thank you. Yeah, I think there is probably some AI training on Twitter discussions. They must, but someone's doing it, right? Someone's doing that. Peppermint tea down. Right, so let's just let's get going with the plan. So we just want multiple instances, right, and some different models. Let's just get started there. So, right, let's close the license down. So, right, we need to go into the header file. Yeah, we've just been in these files basically for the past load of streams. This has been great. Graphics all the way. So we've got ourselves a sphere, right? How do we render the current scene right now? Well, like all good things, it's just an array. It's just an array of spheres. So we have a buffer of spheres. Yeah, spheres buffer ID. Can't get more basic than that. So what we need to do is we need to upgrade this. We need to add more complexity because we want to have models, instances of those models, and as we go, we're going to add more complexity to them because we're going to need it in order to have a massive scene. But we'll start simple because we're not going to, you know, I could just spend ages programming this and then we'll spend ages trying to fix it. So, you know, piece by piece. So I need to think about a model. So what is a model exactly? So again, this is going to change a lot, but for now. So yeah, you can have a model and then an instance of a model. Although just calling it model from someone who's reading the code in the future, they might be like, oh, this is an instance of a model, right? So we should probably give this a name like model description or model blueprint model. I think people call them prefabs. No, but prefab is more, right? A prefab is like the description plus a bunch of variables or something like this sometimes. So I might just call it a model. Or maybe I could just call it a model. Maybe it's fine. Well, I'll think about it. If anyone's got a good name, let me know. But yeah, I'll just keep it for model for now. But essentially, this is a structure on a GPU, so we can't have pointers. So we need to basically have a spheres start index in some massive model spheres array. So we'll probably boot the game up, have a linear address, just a linear array where all the model spheres go, and we'll essentially like clone those spheres out of there, and when we have instances or something like that. Or we might, depending on what the game's like, we might not be able to load them all at once, so we might have to sort of heap allocate these guys. Or maybe destroy the array and boot it up every time we make a level or something like that. But we'll see. So now we're going to probably have this a lot, where we're going to have a spheres start index and then a spheres count. Oh, no. Let's just do this. Keep it simple. I was thinking about making something else, but that's me trying to... hey, Skiffersy. Have you implemented a system to determine which LOD to render? Not yet. We are starting off from 0 to hero. We're here. We're just going to have multiple instances, and we're going to do the different LODs and clusters, hopefully, on Tuesday's stream. We'll probably be starting that one. So let's have an array of spheres. I'm going to go from there. And then a model instance. So you make instances of models. What is this thing? So this is going to be one of those transform 3Ds that we made, right? So this would be your world from local. And then we also need to know, hey, what is my model index? And then we can address, well, so we can access that model and stuff like that. Or, you know, we can do debug renders, all sorts of good stuff with that model index as well. Not just address the model. So those are basically the new structures we're going to need. Now, how are we going to change the thing, right? So this spheres is now model spheres. So it's just where all the spheres for a model goes. Yeah. So we'll change that a bit. And let's keep going. So what do we got to change? Oh yeah, so we also probably want to add a couple other buffers, right? So we want to add a buffer for just, hey, here's a bunch of models. And we're just gonna, like, yeah, there's an array of models. Here's an array of model instances. So it's kind of annoying making these all different buffers sometimes. But yeah, I guess we'll fix the problem later if we need. So we need 2 new buffers. So how many models do we need? Well, we'll just do something like this, right? Models capacity, model instances capacity. You know, maybe we support up to 65,000 models for some reason. I don't know. Number. That's like 160 whatever thousand, but good. Size of model, instances. Alrighty, so we got ourselves the buffers created now. Now it's got to go around and fix up the problems where we. So this is okay. So what we need is we kind of need. So maybe we should delete some of the old code, but essentially we want to place in the code where we create all the models. Yeah, I still think I need another name for it. Maybe I might change it quick. No, fine. I can't think of one. Right, so we'll do model. Yeah, so we basically just want us to go, this is where we create all the model. Create all model or models here procedurally for now. But what we want to have a way where we can instantly switch from a simple scene with one model that we can cycle between, and we want to have a scene where we can just have the whole scene that we're going to be making. And the reason is because we're going to be adding new features, and when we add new features, we only want to test it on the most simplest thing. But yeah. And then when we know it's working on all the simple things, it will just work on the big thing, right? Well, hopefully. That's the idea. But yeah, simple thing first always. So what we need is a new block, because blocks are great. And we want to take all of this code. This builds a BVH as well. I think it'll be fine. Oh, we need to have animated right. I got more things. Somewhere in here as well, we probably want to add dynamic models. So by that I mean like animated. We're not going to be doing proper bone animation yet, but it is something that will come. Because it's not too difficult, but we just need a way, because we construct like a BVH, and we'll probably need to have one BVH per animated model. Okay. So here's the model spheres. We'll just give that a nice new little name. Phone out of the way. Okay. So radio. So we get all that to upload. Fantastic. These are the leaf spheres count. Okay, what does that do again? Right. Okay. So we're definitely going to turn off the BVH for a bit. Resolution. Sure. So this is where we used to control it and apply some form of offset. It's no longer the case anymore. Now we control the camera. This T variable is how we used to animate and give it like a bit of a sine wave. Let's just get rid of this for now. Let's just make things more like I can go and add it back in. It's not a big deal. We used to add a bit of a sine wave offset. It's fine. Okay. more or less x, y, z. S center position dot z plus equal 100. Well, no, we don't want to be adding 100 and moving it 100 in local space. Yeah, so it says snorm to world, snorm to local scale, something like that. Okay. Then we'll get rid of the BVH. Undeclared spheres count. Alright, we'll get the BVH1 working in a bit. We just want to get it working without it for now. No offset. No, where's my... Good. Okay, it's pretty good. So this just creates a 3D volume. So we have a 3D volume going from -1 to 1. We have a step based on the resolution. So there's 20 spheres that go across. Well, yes, 20 by 20 by 20, and we basically we go over every cell in that 20 by 20 by 20, and we just check if we're inside the design distance field between these two spheres on the left and a box in the middle. If we are, we drop a sphere down. Bob's your uncle. But yeah, we'll look into this code later. This basically just prepares the BVH to be built. So that's done. This is the old model thing. Right. Yeah, this is like some old models we used to make, but they can completely go pretty much. I do need to keep some of these variables around. Okay, so these guys can stay here. Hey, the sleeping mushroom, how you doing? How's it going? Right, so now we need a bit of space so we can actually make the instances, right? So what I want is probably another one of these types of guys, right? Well, this is going to be... I think this is going to be... this is the sort of simple scene, and then this is the sort of complex scene, right? So we're just going to construct these scenes here. So what we need now is a... Okay, so we haven't actually put a model down. So... Yeah, I haven't put a model down. Right, let's create enum. Quick and dirty enum. Model dumbbell. So the dumbbell's the first one. Did you sort of resolution, sphere, step size? Yeah, I wonder. I had planned to have different sizes of balls, but maybe that could be done automatically. Huh. Yeah, you can always have a pass over that does something about it. Yeah, this varying ball size. Like, I imagine when you sort of edit, can I run this? Good. I imagine when you sort of edit this thing and you sort of put more balls down, right? Um, the ones near the edge are automatically going to go down to the smallest size. So these ones here, for instance, will all be like divided a lot more. And then ones on the inside will be a step bigger or something like that. And you can also change the sizes of them as well. Like you can stop them from subdividing around the edges if you wanted. So that could easily be a pass. Like each sphere can have a property on it where it says if it's forced to be that size, basically. Right. It's interesting. But we can always have a pass which runs over it. You know, as soon as you make a change in the editor, code's gonna have to run over all these spheres and sort of adjust everything. Because these ones are small on the outside. If I add more spheres which are more outside than those ones, then they should probably shrink up. You know, if they're surrounded, they should not shrink. They should group rather than be divided up, right? And just be bigger. So that could probably be done automatically. And I don't know where we want to do that. Yeah, think about it. We might want to move this before the lodding and cluster stuff. Yeah, we should probably do that. So we could probably automate that. Let's must go. Do you support full affine transforms for the models now? We're working on that. So by affine, let me just double check. Affine means like yeah, we're working on that right now. Yep, we're working on that right now. So when we sort of set these models, it would probably be okay just to copy paste this code and hand code in a few things. Automate the variable size, the ball size. We'll just be plotting points, then have it sort of run like an optimization, not really optimization pass, but you know, a pass over that to modify it or something. And LEDs. Yeah. So for now, we can just put it into memory. Yeah, ellipsoids. Interesting. Oh, will I be able to make ellipsoids, damn it? If I have... That's only if I have non-uniform scaling, right? Or am I missing something? So we also need to make another one on here. Alright, so this one will be the model dumbbell. Only some models. And the model instances will come later. We'll get the buffer ready though. Yeah, non-uniform scaling. Yeah, that's a problem I need to think about. I don't know if ellipsoids will. They could fit in. They could fit in really well. I just need to think how. They might work pretty well with like the lodding system. Yeah, it is included in it is, isn't it? But we could always make it so that we could use, affine transforms, but just ensure that we never get a non-uniform uh, scale. So yeah, I think about it. But if I'm not using non-uniform scale, oh yeah. Yeah, I'll see if I can make it fit into it. Because it would be really great to have a non-uniform scale because the effects you can do, right? You can do the squishy effects, and it's not like it's it can make stuff feel more alive. But then again, I could just offset the sphere positions and do that, right? And it might be okay. But yeah, I'll have to see. Booyah. So, um, we'll probably do like a model dumbbell dot spheres start index, right, equals spheres count, right? And down here, we'll do something like this, right? Spheres count equals spheres count. Take away the start index. Bam. So that looks like we've set up a model. You can make Mickey Mouse with flat ears, with ellipsoids, and fingers and stuff. Ooh, that's true. Hmm. 2024, Mickey will be in the public domain. Gotta be able to build that Mickey Mouse. But yeah, I am kind of fixing stuff to grids when I build these things though, so I'm not sure. But maybe you could have a separate model for the hand, and then you can do with ellipsoids, you can do fingers, maybe. I think the whole thing's gonna be like a lot of this stuff is gonna be based off the fact that it's a known grid. But it could work. Yeah, it could work. You just have it sort of straight, and then you could probably have bones. Yeah, that would solve my problem of maybe have a bone going down each finger, and then they could probably separate or something. That could probably solve my problem where I was thinking that I might not be able to make the spheres small enough to even do fingers, right? Like physically small enough. So you don't even need non-uniform transform in the grid. Yeah, that's the point. Yeah, that's good, isn't it? You have it inside a grid straight, and then you apply the transform to it afterwards. Yeah, I think that could be. Yeah, it could work. Sounds like it could work. What is it like to ray trace like ray tracing an ellipsoid? You said it was not that much different. Like, because you basically have a radius for each. What is this code? What is this language? That's the question. But yeah, I wonder what else it would be. Right, this is all scalarized. But yeah, it looks quite simple. It looks about the same, probably. You just need to transform the ray and adjust the normal. Ah, fair play. Right. Huh. Yeah. Think about that. Right. That's the number of models. So model instances will probably have a count. So the first instance, right? And this is where we can... So, okay. We'll probably just do your model dot model index equals model dumbbell. Ta-da! This is where we get to put the transformation your world from local. So in here, we can build up our matrix. So transform 3D world from local. So what do we want to achieve here? So for this one specifically, this simple scene, we just want to have one. So just put it 100 ahead of us, and we could just rotate it. We could get it to rotate over time as well. We can have that as the thing that we optionally turn on. Yes, so what we'll do then is we'll say we'll probably want a couple of things, right? We'll probably want like a translation. No, I reckon we just want to do it right away. So multiply some sort of transform 3D, two transforms. And I think you want to translate to go... Wait, which way around would it be? View from models only just down here, excellent. Right, translate will go afterwards. Yeah. So it's rotate. Rotate. So probably want to rotate around the y-axis. And we'll probably just have some form of rotation that's just gonna keep going. So static, float. Start it off with something like that. And we'll just increment that by some fixed frame dependent thing, which you can always just comment out very easily. That might be a bit too fast. And then we can simply do a translation. We're going to push it out. So 0, 0, do about 100, so we get it in the same spot as we had before. And then that should be our model instance. I'll obviously do a more complex scene as we go. So build a few models as well. But let's get this working before we do any of that. We'll probably want to get the BVH1 working as well. Okay. So right, what do we need to do now? So we've got an array of model instances. So we ran this is what our frame looks like. We basically, so we'll focus on the tile one first. So we bin the spheres into screen tiles. So all we need to be able to do is we need to go over all of our model instances, and then we need to bin their spheres into screen tiles. Now the number of spheres that we have per model instance is different. It's a different number. So you could basically do a dispatch for each model instance, but then if you have like 1,000 of them, that's 1,000 dispatches. So what you really want is you want to have a way where you could like a way where you could probably do it in 1 or 2 dispatches, right? A fixed number rather than a variable number of dispatches, which is purely commanded by the CPU. Because the more GPU driven we can make this, the better. And we'll probably just go for a GPU driven approach right away. So let's go to this shader. Well, first of all, let's see what yeah, let's disable the Froxels one and disable the BVH one for definite. In the shaders, tile, what was it called? Tile counts, excellent. So this basically gets a sphere index, and it'll roll with that, and try and bin it into a. So what we could do is we could. See, it's much easier if we have them as some form of fixed sized amount. Yeah, so what we might do is right. So there's a way where we group them into some fixed sized amount. So we could probably have one shader which goes over all of the model instances and can say, here's essentially what you want. You like, I don't want to have to go over every single sphere. Yeah, I can't go over every single sphere in a model. In every model yet. I have to find a way to break it down into groups of things first. We do have a group of things at the moment, which we kind of disabled. And that was our leaf nodes in our BVH tree. These group from 1 sphere to 8. But if I did that, each thread probably has to deal with 0 to 8. Sorry, 1 to 8 spheres and have a for loop. See, this problem kind of goes away when you have like clusters, because you can basically ask a model instance how many clusters it has. Does the LOD selection figures out what clusters it has, emits those into an array, and then you can dispatch over all the clusters and then look all the spheres in the clusters. The clusters will probably be a fixed size. You know, maybe you do 256 at most, and you can hard code that. And the closer they are to 256, the better it would be for the parallel algorithm to work with, right? So is there a way we can sort of build in a collection of spheres into the sort of model system without doing clusters yet, but sort of making way for it? We can make, like, ultimately we are just going to have an array of clusters, right? They're going to be processed, I think. So I think maybe we should make some clusters, but they're not going to be... Yeah, maybe we'll do... See, right now our models are going to be dead simple, but we could change them. They could be more complicated. They could be more dense. So I might do... The clusters might be 4 by 4 by 4. And then that way it's 64, right? And we'll just break into 64s right now, but they won't be 4 by 4 by 4 yet. Just in the future when we do clusters, they might be 4 by 4 by 4. And that way we can do it in a single... We can hardcode that number to 64. When we process a cluster. We might have to change that number though, but we'll see. I think we'll go with that plan for now. So let's break it into sort of these clusters, maybe. Yeah, but then you've got to like... You know what? For now, let's just do it all from... Or we could just make a dead... Yeah. For now, let's just make a slow shader that just does the job. Because I feel like we're just going to make something which is just going to get chucked away anyway. So just make something that just does the job and just make it probably as simple as possible. So let's just make... So what problem have we got to solve then? So you're binning these, each sphere from A. Okay, so we're going to make one shader which goes... Yeah, we'll just do a dispatch for every model instance. It's going to be terrible, but we don't have that problem yet. Yeah, it's a terrible design, but we don't have that problem yet. So we'll make it more scalable when we do sort of LODs and stuff like that. Got it. So for now, we're going to do a dispatch per. Okay. This can work. So let's just write the shader code first. So this one is going to be like, just say, emit spheres. So just emits them. Should it just emit them into world space? Pick them up in world space. Something like that. Maybe. So the job of this one is it's going to get like probably a thread per. Yeah, so we could probably just do an if statement. Right, if that's more. So you'd be able to fish out the model. With the from the constants, get the model index. And then from there, you can get the number of spheres. Boom. Then you basically just sort of emit that into a buffer. We'll probably just but wait, where am I going to get this start index to sort of allocate? Because we could have a couple of instances, you see. Where are we going to get the start index to sort of bin them in there? Well, you could do a two-pass system, right, and keep track of where they need to go, and then the instance. So you could basically just allocate them. So you can allocate a sphere's start index for each one. Something like that. Just do an alloc instance spheres. So for that one, you could probably just bump something in some form of like global. Instance model instance spheres allocated next, something like that. We'll bump that guy with an atomic. So you just do sort of like an atomic add into global this thing. Take the address. And the result is what it was when you read it. Wait, what are we adding? We're adding this many spheres, and then we're storing that inside model instances, model instance index, dot sphere start index. So we'll sort of allocate all that, and then we can basically use this with a sort of like a plus a sphere index to then just throw it into a sort of like an array of spheres. So we need like a spheres buffer, where it's just going to plop it in there. And we'll just throw in model spheres sphere index. Model dot spheres star index. Okay, so we'll just copy them out of that sort of model blueprint, and then just duplicate and sort of put it into the into one big linear array. Not a good idea to scale, but until we get LODs and stuff like this, it will do. Okay. The Rust borrow checker continues to disappoint. I simply just don't find it practical for writing code. Yeah. That's basically where the like when I used to program in Rust, that's where I ended up at. That's why I went back to C. Because it just got in the way eventually, you know. It was you know, I think it's great. A great language for people to come down from, maybe like a higher level language. But yeah, it does you know, and for me, I sort of took apart the sort of standard library and made my own standard library, and you know, I was learning a lot of low level stuff with it. Yeah, then it just felt like it was getting in the way. But it was a good experience though. You know. But I think one of the biggest problems with Rust, or people using Rust, is they don't really take stuff apart. They just happily use something from cargo, and they've got like, you know, 250 dependencies they're pulling in to build their project, when they probably don't need like 0, you know. So maybe it isn't the best thing for people to come down from, but I don't know. If they can get out of that habit, then it could be quite good experience, I think. Every time I start making progress and lay a good foundation for code, the borrow checker comes in and F still up. Yeah, multiple mutable borrow. Then you have to sort of move a collection of field or a bunch of fields into a substructure somewhere, and yeah, take the reference on that substructure and a different substructure. Yeah, pain in the butt. All right, so we're just gonna let's just double check this code. We'll make these and we'll fire these boys off. So allocate model in no irritating thing about it. I have no clue how to go about it. Oh great. Yeah. No, easy. Unsafe. Unsafe. That's all you need. Magic keyword. Right, so we're basically just gonna get the model. If the sphere's out of bounds, okay. Wait, you're just going over every single model here. You're not going over every single sphere here. So what you're really saying is if the model index is greater than the number of models. Right. Jobs are good one. What's the model index? Good point. What model index is this boy here? Right. Then. Oh no, this is an instance. Shoot. So I think these instances could go in the number of models. These can go in the globals. Might be useful. Put those in there. So that'll just be a global. So where's my instance? Here it is. Model instance. Cool, so you get your model instance, and from your instance you can get your model. Great. So basically we allocate inside some array. That stores it back in there. Since we can't have pointers, well, you can have pointers, but they're logical pointers. Okay. This is fine. This one is going to go over every single sphere. So we'll probably have something similar like this when we do clusters. We'll probably just be like, allocate, calculate how many clusters I'm going to have. And you sort of then make an array of clusters or something like this. Something like that. Unsafe does not escape the borrow checker? Well, it does in a way, because your problem is the multiple borrow, right? You just take a reference, turn it into an unsafe pointer, then turn it back into a reference again, right? Yes, this one goes over every sphere for a model. We dispatch it once per model instance, which is terrible, but we're just trying to put something in, right? Get the sphere index, get the model index that we're going for. No, it should be the instance. Then we need the model. Need the model right away. Copy from the model spheres into this other one called sphere. So we'll call it model instance spheres. We need to make that. Okay, these are our two guys that we have. And then the rest of the shaders don't need to be changed much. Just we use this array instead. So we now need to make these two data structures. So we'll just make these boys here. Okay, so what does this one need? Well, it needs a it needs a buffer, read, write, or write only. Or is it read or write? It really doesn't matter. That's what it is. And it's just a bunch of model instances. And then we need the array of models as well. Okay, so there's this boy. Let's keep the naming convention. And the other one is this boy here. So with this one, what do we need? We need an instance index. You need an array, 2 arrays of spheres, isn't it? Sphere. We need the model spheres and the model instances spheres. So let's get these right. In terms of the rewrite permissions and all that jazz. So this one only wants read-only access to the model, but read-write to the instances. This one wants read-only, 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 read-write. Okay, now what these guys, they kind of need to go near the top. Let's pop them in here. All right, so we're going to fill these boys in. We've also got to fill in the globals as well. So where do they go? Where's the tile? There we go. Oh no. All right. Okay. So this one, I'm just going to instantiate this to 0. Let's call it BC. So BC models is equal to the GPU resource ID index of the GFX model buffer. We then want the model instances, which is obviously the instances. Good. And that's all we need. Then we can do synchronization code, which is something like this. Read write on that. Read only on this. But anyway, okay, that's fine. Then we need to do a dispatch. And we're dispatching on this thing, which I kind of forgot the name. I think it's alloc. Oh yeah, it should just be the same as this one. Model instance spheres. Something like that. And how many of these we're dispatching? What's the number of instances that we have? So we're just going to do model instances count. That's a little local variable that we have. And that should be everything we need. Now there's another one. Basically copy paste of that. You got rid of all that red there. So this time we actually need to make another buffer, but it's not too difficult, right? So model spheres already exists, but we need the instance spheres. Yeah, just make that one. Let's follow that one, drop that in there. That ought to be good enough, I reckon. Jobs again. So there's a one more thing, and that is a model instance index. So we actually need to make a for loop that literally just does all of those boys right there. So 0 to model instances count, do a dispatch for each one. Not good, but for now it's fine. Okay. We need to do a dispatch, obviously. And also, why isn't this oh, sphere? Do that. Yeah, so I have a code generator in my compiler which basically makes this name as an enum. So we basically just pass in an enum for a shader. Oh, I was right. It's just not compiled it yet, that's fine. So do another dispatch. This time it's dispatching. We need to put the sync code in there. That is true. So rather than alloc, it's emit. Just paste it in just in case. Right, sync code needs to go in. I think it's read write all the way except for the last one. So read only all the way except for the last one. So instances, spheres. Why did I do this to myself? Okay, that one. Buffer ID. Pretty cool. Why? Instances, spheres, right. Okay, it doesn't matter about the... I'll get renamed anyway, or deleted at some point. Cool. Right, so they're just gonna basically make an array of all the spheres now for every single instance, which is great. So where do we need to go next? So we've got this globals thing. It's got 3 new fields. This is accessible on every single shader. Super handy. We made it last stream when we made the camera stuff. So where's the view from world? So right about here we put in all the things. So the allocated starts off at 0. We've got a number of models, right? Model count, and then we've got a variable called that as well. Sweet. So awesome. Now, what is next, right? So we've now got an array of spheres. So now we just need to fix up some of these shaders. So this is where we calculate how many spheres are binned into a single tile. So this is some occlusion, the old occlusion buffer code, so we just ignore that. So this spheres array, yeah, it should we rename it? No, we guess we don't have to rename it. Yeah, I think we can just give it. So we need a total number of spheres. It's kind of going to be GPU driven anyway, so we could have it in the. It's here, right? This thing. So rather than having that, we just like, yeah, we should make that GPU driven, right? Allocated. Allocated on GPU. So it's just gonna like bump it. All right. So then all of these guys that need the spheres count can now just go. So that spheres count goes tile spheres. Yes, this needs the number of spheres. Right, get rid of that. Froxel, get rid of that one. Froxel binning. That's the other renderer. Then there's the BVH. We'll do the BVH in a bit. Let's just worry about the Froxel and the tile one for now. So CPU side, if we just hit compile, we should be able to find all the guys. Oh, this should be add U32. Right? Yeah, what's this one doing? Oh. That's a sphere copy into a sphere. What's the problem? Oh. Oh. Got an S in there. Right, so enough spheres can't anymore. Instead, this is just a GFX globals, not global. So this is model instance spheres count for now. So we need to actually replace all those spheres counts with that. Is there any more of those BC spheres counts? Should be a few. Ah, you bugger. Any more? There's one here. What's that for? Is this for the ray tracer? Sorry, the BVH. Yeah, this is for the BVH. Yeah, we'll do that one later. Okay, so what's going on here? So no longer have a spheres buffer anymore. Instead, we pass in the model instances spheres. Instance spheres, I think I called it. No biggie, we'll just go around and do all that. Even in the BVH one, I guess. So in the collision code, which is going to be deleted anyway. Okay. Nearly there. All these need to get deleted. Spheres count. Well, we don't know the number of spheres anymore. Gotta be a dispatch indirect. Bum bum bum. Plot twist. Technically, we do know the number of spheres. CPU side, though. But in the future, it's going to be GPU driven anyway. So we kind of want to do the indirect. Luckily, I have one of these boys. But, yeah. I think we'll just stick the dispatch args inside the global thing. Just this globals is just going to be accessible everywhere. Where have we got these dispatch? Let's go to my GPU system. Is it in shared? Oh, come on, it should be in there. Where's the indirector? Here it is. In my face. I don't think I've got one of these data structures yet, to be fair. Okay. Let's make one. GPU dispatch indirect args. So basically on the GPU we can fill this in and then it's like, oh, I want to launch this many groups. So you basically just have, well, it's just a uint 32 times 3. Yeah, I don't know why I need a whole data structure for that, sorry. Of course, that's the reason why I didn't do it. So yeah, we just do, so we'll do like a tile binning, where is it? Tile binning dispatch. Yeah, tile binning. Oh, excuse me. Dispatch. Something like that. So it points that from the CPU. GPU fills it in, and we launch that boy off. So we need another one of those, probably for the Froxel binning as well. But yeah, it's not too difficult. So we've got to fill that in. yeah, we just kind of got to fill that in somewhere. So CPU side, we go okay. Indirect, then this is basically all pointless. We give it a buffer. What buffer are we going to give it? I think I just want, we put it in the... oh no, I need to use GPU. Alright, resource index. No, that's not going to do us any good. Where's the way I can get access to it, to that globals buffer? I need that globals one. Right, that needs to come with me. Okay, global buffer. So that's where that big global structure lives, is just in the global buffer. It's accessible via every shader via a constant index. So it's very easy to access. But yeah, we just want to point to it from there. There's also an offset. Yes, the offset is offset of globals, right? And we're offsetting based on this field here. Boom. So that's great. So we want to do that same sort of thing for when we do the binning pass, which is basically the same shader, but it just actually bins them rather than counting. Again, that's got to change in the future, but for now, it does the job. So, yeah, that'd be good. So, what is this? Oh, tiles, that's fine. Right, so we've disabled the Froxel one for now. Don't care about that yet. We'll fix that in a bit. GPU side, though, we've got to fill in those arguments, right? So those new things that we made, I think it was like a MIP. There's this one, right? This one, right, so we basically have to find, like, yeah, okay, so we're going to do an atomic add on that global. Yeah, let's do it again, right? In just another place. But it's in that, so they need to be initialized to 0. Damn it. Or, right, dot x. Same with the Froxel. Alright, so that's just gonna atomically increment those guys, but we need to initialize them CPU side because if we don't, they're just gonna be accumulated every... Oh no, they could be random stack garbage. Oh no, yeah, there'll be random garbage from the upload buffer or something like that. Not gonna be good. So we need to basically plop those in there. Dot x equals 0 because we're gonna accumulate that one. Y and z needs to be 1 because if not, it doesn't work. The dispatch. This, it'll be doing times in something by 0, so it just won't work. Don't dispatch anything. So that's everything initialized fine. These will get filled in by the GPU. Cool, so I think we're actually there. So this is where the computer can blow up. Can Henry read raw machine code, I wonder? No. I'm not that much of a machine. I can read assembly, but it takes a bit. I can read. I can probably write assembly very slowly by having a reference manual to the side of me looking at it and trying to figure out the syntax. But yeah, like I understand assembly, but I can't. It takes me ages to write it, right? You know, but I can read it. Handwritten assembly would definitely be better than compiler assembly, but for me, because I've not, yeah. Okay, so I think we've disabled everything. Yes, this is where the computer can blow up and the stream could die, but it's fine because I'll be right back if that is the case. But we're only going to be launching it for the screen space tile ones. The Froxel binning is disabled, and the Froxel ray tracer is disabled, and so is the BVH one. Okay, so we should just be seeing a single model, right? Then we'll do 2 models, and then we'll get the other renderers working. So it should be rotating as well. It should be translated a bit further out from the camera. So if the stream dies, I shall be right back, but hopefully it shouldn't. Okay, stream's not dead yet. What are we doing? Have we filled up the upload buffer? Yeah, I think we just filled up the upload buffer is all. So how we fix that is we just hop into the GPU system, wherever that constant is. Where's that assertion? GPU.c. So what line again? 175. So we'll grab this and we'll make it 16 megabytes. Or maybe we'll make it 32. You know, I like a good 64. Right. If the stream dies, I'll be right back. Hopefully not. Alright, we're running. But we're not seeing anything. They're taking a long time. Oh, they're not now. They did for a second. They're taking many milliseconds. Now they're dirt cheap. So these are definitely running right, which is good. Let's run that again. Yeah, see, they're taking 2 point whatever milliseconds, and then yeah, these two are, and then they kind of stopped for a bit. Very weird. So what have we done? That is the question. So we have a printing functionality, right? So prepare to be blown. So we'll just go, okay, if sphere index equals 0, GPU hprintf, this equal that, this, and voila. No, I can't put breakpoints in. Doesn't work. Yeah, debuggers are not that great on GPU. So you get 207 printed at every frame. That seems correct, right? Because there's only one instance of that 207 sphere. So that's cool. Why isn't it being binned? Right. So these are in sphere. Right, so we didn't do any transform. That's where we're missing that. So if we put it in local space, it's probably like, put it in local space. We've not applied any transform. So we're transforming it from world from view. But what we should really have is this thing. We should really have a transform going from local. Yeah, so what we're going to do is we're going to transform these guys in here. So we'll do this sort of like multiply, transform. For now, we'll just do this, right? Instance, damn it. Instance dot world from local. So that brings it from local space into the world. I'll dump it in there. We're probably not going to be doing that when we do the clustering stuff, although we'll keep that. Oh wait, that's not going to. I need to call transform sphere. I've got a function which basically transforms the sphere. Does the radius and the position. Right, fingers crossed it doesn't die. Right, still running. Okay. So now what we should debug is, so we should just follow a sphere, right? And just debug it this way. So hey, what is my, so this is in view space, right? What is my position? I left my Discord open. No. Yeah, so we were just gonna debug print pos f f f. Yeah. So sphere 0, see where this guy is. Right, so this boy is all over the place. It doesn't sit still. Okay. There's a problem. This boy. So we upload our spheres to the model every frame. Right, so what we didn't debug is like, we didn't actually debug this, right? So you'll just be like, sphere equal that. And let's just see what we're reading. And this is be in local space, right? See if that stays consistent. If it stays consistent, then it's the transform or the reading. So this doesn't say consistent either. There's two things which are all over the place. That's a bit weird. It looks like we're getting some form of data race. So we shouldn't be. So model spheres. Model spheres, we just set it to that spheres buffer thing here, right? There it is there. We're uploading the whole thing. We're not even uploading it. We're putting it into the G spheres because it gets sorted. Right, so for now, we'll just do a straight copy. Model spheres. Right, that should work. Okay. What the hell's going on? Okay, it's doing the rotating. It's rotating around the world though. But for now, let's turn it off. Alright. Oh, it is. It's a bit broken. Doesn't look like a dumbbell anymore, does it? So what is the problem? There's a minus 100 here. Oh, sorry, that's the other code. We can get rid of that when we... Alright, that's good. This is when we build the BVH. We'll worry about that in a bit. Yeah, it's 20 by 20 by 20. It's close though. Yeah. So what? Am I seeing 16 by 16? Yeah, I'm seeing an odd sphere here as well. Feels like a transform problem, maybe. I don't know though. Like, if we just did that, what happens? Same thing. Right. So your transform goes in there. Okay, so that seems fine. We're setting a start index there. It gets put in there like so. Hey Wajilla, how you doing? Welcome. How's it going? How we doing? To translate into world space from local space for this sphere, copy it over. I don't know, it feels like I don't know if it's a transform problem though. Very weird. Oh. Oh, are we dispatching way too much? This is the number of groups. So when you say, oh, I'm adding this many spheres, you need to have this number. Okay, this could be part of the issue. We're reading a bunch of... I don't know. So this needs to be divided by 32 because we launched 32 locally, right? Although... it should stop. when it reaches this count anyway. Right, let's just note that down so we're aware that that is an actual bug, but we're probably not gonna fix it because we might be throwing it away anyway. So it's just temporary code, very temporary code. So sphere index. So you pull out your sphere, do your view from world transform on it, bring it to view space. I could debug print more of them, but there's 207 of these guys. Let's see what happens. So let's get rid of this one here. All right. Okay, we're getting a lot of crap data. So the first so many are fine. It's when you go after the first so many. So why? Oh why? Oh why? Is it so? We must not be copying enough, right? Yeah. How many of these guys are we dispatching? Yes. Okay. I know the problem. I know the issue. I know the problem. So we're going to do our dispatch indirect. Well, not indirect, but the one's just above that. These guys. This one is doing the number of model instances, but what you want to do is dispatch based on the number of actual spheres. Crap, what did I do? So we should probably use these dispatch args. Oh, no. Number of spheres for your model. That's what we need. So model. Yeah, but how do I know what index you are? I'm gonna be able to read it from the upload buffer. Super sketchy. Shouldn't do this, but it'll work for now. Model index, models, spheres count. Terrible. I'll do it. Ta-da! A model instance. Yay! So now, so we'll have one of those before. Okay, so we'll make more. I swear. So let's just do another one. So now, this is easy. Wait, we can do a rotate. I think we want to translate these the other way around. I think that's the way we want to do it. Oh, look at that. Now I'm going to build another one of those spinning dumbbells. Doing alright? Awesome. Nearing that Christmas holiday. I'm going to do like a negative 50 and a positive 50. And maybe we'll do like a 200 away from the camera or something. And then we'll rotate around the x-axis. Right. So yeah, if the computer dies, I'll be right back. You know the drill. Shouldn't die though. Oh yeah. Model instances. Would you look at that? Dumbbells for the win. Why am I didn't So we've got to get the Froxel renderer working. Froxel binning working again. This is screen space binning. So we're binning into screen tiles. That feels good. Exactly. This one. This one's like, you know, this one's definitely like gonna. It's gonna mow some lawn or pick up some crops. You know, laying some crops down. Timings are all over, are they? Oh no. Yeah, when you go right into the screen. Yeah, yeah, yeah. They it's because it's binning all of them into like a single tile or some into it's binning like all of them into a single tile or something like that, and then it just busts. That happens because we fill up a tile with 256 spheres. Wait, we went around that problem. I fixed that problem, so I don't know what this is actually. But anyway, yeah, on the road to making it better, that's for sure. Maybe I should keep the effect. The stream is freezing. Oh. Does it happen when I go through the balls? Does it happen when I go through the balls or something? What's the problem? Fully frozen? No. No way. Is it back?